Hello viewers, today we will solve a problem based on the speed control of DC shunt motor by resistance method. So our question is, a DC shunt motor takes an armature current of 20 ampere from a 220 volt supply. Armature circuit resistance is 0.50 ohm. For reducing the speed by 50%, calculate the resistance required in series with the armature if the load torque is constant, and second condition is the load torque is proportional to the square of the speed. So first we will write the given values. So IA1 is given as, the armature current is given as 20 ampere, supply is given as 220 volt, and armature resistance RA1 is given as 0.50 ohm. Now we have to reduce our speed by 50%. Let's take the initial speed N1 and we have to reduce the speed N2 is equals to 50% of N1, so 0.5 of N1. Now we will calculate our first part. So A is when the load torque is constant. So when the load torque is constant, we have to calculate the load torque is constant, so is equals to constant. This is the given condition. We know that for shunt motor, because the flux is constant, magnetic flux is field flux, it is in field flux is constant, so E is directly proportional to EMF produced is directly proportional to N speed. So we can write it as E2 divided by E1 is equals to N2 divided by N1. So first we will calculate the E1. So from the circuit E1 is equals to, we will apply the KVL rule here. So the given voltage is 220 volt minus IA is 20 ampere and RA is 0.5. So our E1 will be 220 minus 10, it is 210 volt. Now we can calculate E2 by solving this equation. So E2 will be, E2 is equals to E1 is 210 into N2 is 0.5 of N1. So 0.5 of N1 divided by N1. So it will cancel out and our answer will be 105 volt. So we have calculated the E2 and now we have to find the armature resistance that is connected with the series with the armature resistance. So new resistance, and the given condition is that torque is constant. So we know that for the shunt motor, torque is directly proportional to IA. So when the torque is constant, so IA will be also constant. So IA2 will be equals to IA1. So now we can calculate the resistance required, so by applying the KVL rule. So E2 will be equals to V minus IA2 into R2, which is connected in the armature resistance. So E2 is 105 equals to V is 220 minus IA2 is same as IA1, it is 20 ampere into R2. So from here R2 will be equal to 220 minus 105, so it is 115 divided by 20, so R2 will be 5.75 ohm. So what is the extra resistance connected? So R which is connected in series with the R1 is R2 minus R1. So R2 is 5.75 minus R1 was 0.5 ohm. So it will be 5.25 ohm. So we have to connect 5.25 in series with armature resistance or Ra1 to increase the speed by to decrease the speed by 50%, to decrease speed by 50%. So this is our first part answer. Now we will move toward the second part. The load torque is proportional to the square of the speed. Our condition is that when the load torque will be proportional to the square of the speed. So second part will be load torque is directly proportional to n square of the speed, and we know that for shunt motor torque is directly proportional to Ia. So from here we can say that it is also proportional to Ia. So we can infer from this that Ia will be directly proportional to n square. So we can write it as Ia2 divided by Ia1 is equals to n2 by n1 to the power 2. So from here we can calculate the Ia2. So Ia2 will be equals to Ia1. Ia1 was 20 ampere and n2 is 0.5 n1 divided by n1. So square. So it will be 20 into 0.5 to the power 2 is 0.25. So Ia2 will be equal to 5 ampere. This will be 5 ampere. Now the armature current is 5 ampere. So we have to calculate the resistance. Now, so the E2 will be same because the speed is same for the second condition. So E2 will be 105 volt. Now we have to calculate the extra resistance that is connected to the armature circuit. So E2 is equals to, now using KVL, E2 is equals to V minus Ia2 into R2. So E2 is 105 volt is equals to V is 220 volt minus Ia2 is 5 ampere into R2. So R2 will be 220 minus 105 is 115 divided by 5 is equals to 23 ohm. So the extra resistance connected is R series is equals to R2 minus R1. So 23 ohm minus the resistance was initially 0.5, so it is 22.5 ohm. Resistance will be connected in series with the armature resistance to reduce the speed by 50% when the torque is proportional to the square of the speed. Thank you. Like and subscribe the channel.